Hey, what's up, everybody? Thanks for tuning in for today's webcast to learn how NETGEAR's M4300 can provide enterprise performance and scalability for an SMB-sized price. Brought to you by NETGEAR. Before we get started, I do want to remind everyone this webinar is being recorded. If you have to step away for any reason, you will get an email from us with a link to view the webinar on demand in just a couple days. Also, if you have to step out for any reason, also there's a Q&A box on the screen. I encourage you to submit your questions throughout the presentation, and if we aren't able to get to your questions live, we will be able to follow up with you after the event. There's also a live chat, so just go ahead and pop open those widgets at the bottom and take a look at all the things we have in store for you. Now let's get started. Our presenter today is Laurent Messiah, Senior PLM for Smart and Managed Switches. So Laurent, whenever you're ready, take it away.
Thank you very much. Hi everyone, good morning or good afternoon. This is Laurent Messiah. I'm from NETGEAR. I'm the PLM for the Smart and Managed Switches. That's a real pleasure for me today to go over this presentation. That's a funny name. Don't leave your network in the dark. But I hope that's going to be a good one for you. We prepared a hands-on demo after those few slides. So my schedule today is really about half presentation will go fast and half hands-on demo so that you can really see how we set up a spine and leaf good stack on the 4300 series. So without further ado, let's start with this small introduction. Just want to remind everyone that NETGEAR is fairly different from all other big guys, enterprise vendors in the market, because we do focus on SMB only. How do we do that? For 25 years now, we have reliable, affordable, and really easy to use solutions for networking, Ethernet, storage, wireless, and switching, obviously. What does it mean exactly? Reliable means high-end componentry with highest MTBF time, so that we can give that lifetime warranty. And at NETGEAR, the lifetime warranty is really lifetime. If one of your customers or yourself buy a NETGEAR switch covered by this ProSafe lifetime warranty today, in 20 or even 25 years from now, this product will be obsolete and replaced maybe 20 times, but guess what? NETGEAR will replace it for free next business day. That's how we commit for the highest quality standards. Affordable, well, there's nothing to say here. Obviously, as a SMB specialist, we must be largely under HPE, Cisco, or any other big guy. Last but not the least, we strive to simplify our web interface, because today it's all about switching. We'll manipulate the command line interface, the Telnet or SSH quite a bit, but you know, at the end of the day, we cannot simplify CLI. What we do simplify is the web interface. Our GUI are intuitive enough so that even non-specialist customers can manipulate and configure our solutions. Reliable, affordable, and easy to use. So, we are going to go over switching matter today, but we also have wireless Wi-Fi solutions and storage solutions. So when you look at NETGEAR, don't forget that we cover pretty much the entire spectrum for SMB customers. Okay, so we do have a lot of switching. As a PLM, I handle the right-hand side of that big chart, starting with smart managed and smart stackable and fully managed platforms up to the chassis. Today, we want to focus on the 4300 series, the new latest top of the line for stackable layer 2, layer 3 series, and this very new high-end stacking topology that is called officially spine and leaf on the market. So before we start this spine and leaf story, did you know that we strive not only with the web interface so that we simplify the ongoing management tasks or even installation, but also we spend a lot of time with all these internal components to build innovative cases and form factors. So virtually anywhere, we did that a couple of years ago with those click switches that are great outside of the rack. You will see with the 4300 today, those half-width new form factors that are good for top of rack, and we have this latest easy mount solid metal case attached method easy mount with the 4200 and new smart managed switches as well as plus switches, so that we can deploy PWE installations, for instance, far away from the rack, still with a rack mount kit. So innovation with software, innovation with hardware. Let's go to the point with this 10 gig topic, because Spine and Leaf is all about 10 gigabit. Why 10 gigabit is so important? Because, well, that's the only real solution for aggregating all these bandwidth coming from everywhere in the network, especially from your access layer with cloud activities, with storage virtualization, with this gigabit to the desktop previous deployments that we all had in the past. 10 gigabit is there to address all these bottleneck issues. And we do it pretty right at NETGEAR. You're probably going to be surprised if I tell you that NETGEAR actually is the #1 in this 10 gigabit switching market. So you should read the small print there. We look at all 10 gigabit switches sold in the United States and North America, including Canada, and in the large Europe with 17 countries in the old Europe. And we only look at those 10 gigabit switches that are sold from distribution with these analysts, context, and NPD, so that we just exclude switches with more than 48 ports, because we don't have any switches with more than 48 ports. So for switches ranging from 8 ports to 48 ports, all categories included, and last thing, transacting for under $10,000. Why? Because you know what? We don't have any switch costing more than $5,000 or $6,000 anywhere, so it makes no sense. All switches from 8 ports to 48 ports under the $10,000 bar in US and Europe combined in units, NETGEAR market share is very high. That is a big proof point, because we do have our third generation of 10 gigabit switches shipping now in these SMB channels for small to medium enterprise customers for a while, actually for almost 10 years now, and we really helped lowering the price, making it accessible and affordable enough for our customers. Okay, are you ready? Now we have these 4300 Intelligent Edge series that launched last year. They are brand new. This is the new top of the line for us with stackable gigabit switches, 1 gig switches with 10 gig uplinks, and full pure 10 gig switches, and they all stack together. That's a family with unified software ranging from 24 port 1 gig all the way up to the 48 port 10 gig port count. We stack those switches with many stacking topologies. Stacking is a matter of importance at NETGEAR, coming from the Bay networks from the old days at Nortel, when NETGEAR was only a subsidiary from Nortel, and we kept that good stacking technology and we improved it so that today we can come with standard stacking topologies, but also those high-end, highly scalable, unique spine and leaf. So let me take you through that. 4300 family, that's a pretty big family now, and we have more to come, by the way. You can see now those 10 gig models. You have those half width, half switches. On the left-hand side, the 8X8F, the 12X 12F, and the 24X are great switches because they have a very small footprint. They can go to a rack with the rack mount kit as a single switch, but half width, so that we can squeeze and add another switch later in that same RU for adding resiliency or when it's time to grow. We then have those full width 24 and 48 port versions that you can see on the right. That big thing about 4300 is all about copper and fiber. We have plenty full of copper and fiber because with 10 gig, you really don't know what will come next for your new servers or workstations. On the 1 gig side, that's really straightforward. We have 24 and 48 port platforms with each time 4 port 10 gig uplinks, 2 copper ports for base T, and 2 fiber ports for SFP plus transceivers, and we do that in PoE and non-PoE mode. So 2448 non-PoE and 2448 PoE plus. Those switches can scale up to the PoE plus full provisioning. How? Well, we have 2 SKUs each time for every of them. Means that we have a PA version for a mid-size power supplies and a PB version with a huge 1000 watts PSU, so that we can scale up to the 24 or 48 ports PoE plus full power. Okay, so I will address all the questions later during the QA session, but please go ahead and continue to ask questions during that time in the chat box. That's very much appreciated. Okay, from a software standpoint, that's not really the point today. Just know that, well, it's a full layer 2/layer 3/layer 4 stack. It means that we support dynamic routing from OSPF to VRP to multicast routing. We have OpenFlow 1.3 agent for future use. Maybe if you did not deploy any OVS or Open Daylight controller as of yet. And also we have all the necessary components for a perfect convergence, as well as highest level of security with radius and more. Okay, let's come to the topic today, target applications. We can do many things with a fairly high-end layer 2, layer 3 platform. On the building one, on the top left, we have this top-of-rack application, which is well known now. As soon as you have some virtualization going on, as soon as you have some servers and storage bays or hosts, you want to have 10 gig connections, and it's always better when those connections can be dual homed, right, with multiple links to multiple switches for higher availability. And it's even better when those switches, like these half-width stackable 4300 switches, can be on the same RU, so that you save room and place on the rack, and still provide high-end LACP capability with super nice stacking. Second, building two, that's the fairly common PoE deployments. Instead of deploying a whole lot of PoE switches here and there in campus or K-12 schools, it's always better to regroup those switches into virtual chassis stacks, so that we have only one big switch to manage, only one big switch to install, and later on to maintain. And the third building on the lower right, that's the matter today. That's what we want to explore together, this spine and leaf newest topologies that NETGEAR can bring today to the SMB customers with these 4300s. Let me talk about that right now. So what is spine and leaf? We are going to see that from a pure stacking standpoint. That's fairly easy. We actually are going to stack from the edge at the access those 1 gig switches, 1 gigabit switches with 10 gig uplinks, stack them with 10 gigabit core switches if you wish. So that's a edge to core stacking. That was kind of a dream maybe 5 or maybe more 10 years ago, when we were saying, well, one day would love to stack those 1 gig and 10 gig switches together. And guess what? It was not possible. We actually did it. And we are not the first. Super high-end big Cisco's 3750 can do it as well, but, well, that's not the same product category. That's not the same price tag either. And spine and leaf is very unique to NETGEAR. Even at Cisco with the highest end catalyst switches, spine and leaf is not yet still authorized. Stacking topologies still look like Thunderbird ring topologies. Let's explore the spine and leaf right now. What's that? Well, you want to compare a traditional 3-tier model that fancy large data centers use for a while, with a core layer, a distribution layer with aggregation switches, and access layer switches. This 3-tier model, you know, is around for maybe 20 or 25 years now, but that's not very well adapted to a new data center, heavy applications like Hadoop or even heavy eastbound, westbound application. Why? Because the communication between those access switches from east to the west and back is not great. With traditional three-tier model, you have spanning tree links most of the time. It means that many links are down, hence the switching and routing capability between access switches is fairly narrow. In these old days, we were saying that 20-to-1 or 30-to-1 or 40-to-1 oversubscription was okay. True, that was okay 20 years ago in large universities in the US, but that's not the case anymore in modern and dynamic networks. On the right-hand side, you can now see what is in the data centers and what's going to be in the NETGEAR interpretation of that for a typical SMB network, a spine leaf-based network. This time we have non-blocking topology because we can have those core aggregation switches that we call them spine switches, and they all connect these access layer switches that are called leaf switches. Each single blue line can maybe show a 10 gig link, so we now can have multiple 10 gig links from the leaf switches up to the spine switches, ensuring perfect availability with the highest redundancy, but also line rate capabilities from east to east for all the interleaf traffic. And if that's a requirement, you will see how great it is. Okay, let's dig into that. First of all, I want to demystify that a little bit, okay? Spine leaf can be quite complex, and the scale can be quite large in big data centers. Back to the real world, in our SMB architecture, with this stacking topology of up to 8 switches in the same logical stack, you see on the left-hand side a typical ring stacking topology, okay? Cisco Catalyst, all the previous NETGEAR switches forever, we always had those ring stacking topologies, which were great, by the way. You have the first switch, usually that's meant to be the master switch, the master management unit, connecting to the second switch, which is the backup master usually, and then going to the third one, which is a member, going to the fourth one, and going back, for instance, to the first one for the redundant link. With spine leaf, we do the exact same easy to install, easy to deploy stacking thing, but this time we use 10 gig spine switches, and instead of building a ring, we are going to create a star topology so that every single member behind, under the spine, every single leaf 1 gig switch connect to both, in aggregation to the core, to both spine switches. And by doing that, we can actually reach a dream, a line rate network. Let me show you how. Before we look at the actual plumbing and where we are going to connect those ports, I need to make a stop there, right? Because M43s just can't stop. Let me tell you about that. You have two different kinds of stacking in this world. Coming from HP, going to Arista, going to Cisco, small business, or even Catalyst, Enterprise, 3750s and higher, you can divide the overall stacking switch product category, layer 2, layer 3, whatsoever, into two different buckets. Do you know what it is? Well, that's those stacks that can stop, and those are the stacks that just can't stop. The stacks that just can't stop usually comes with those enterprise class, world class, hitless failover with non-stop forwarding. Hitless failover and non-stop forwarding means that if something bad happens, and you know, well, when something can happen, well, some of us will say that it's going to happen. When something bad happens on one switch, even if it's the master switch, the process will instantly, in far less than a second, the system will elect a new master without any service interruption for any other switch in the stack, meaning that this stacking topology is always alive because there is a non-stop forwarding process for layer 2 operations, layer 3 operations, and all the services like spanning tree and whatsoever. M4300 comes with the highest end hitless failover feature called non-stop forwarding. That's what gives that quite interesting thing with Spineleaf, because not only we are going to have line rate capabilities and high performance on the network, but also we can commit for a highest availability with absolutely 0% chance of downtime. Let me illustrate that. First application for Spineleaf is a simple Q spine 10 gig switches at the top, such as those half-width 12X, 12F, and we have two of them. We are going to connect them using copper or fiber whatsoever. We can go up to 16 ports as stacking ports on every 10 gig switch. So it means we are really free, and maybe you are going to be much more inventive than me with fancy grid or mesh stacking topologies that nobody really thought about as of yet. Back to that 4300 current first example, we have those two switches stacked together with two stacking links, maybe with a DAC SFP plus cable, and we are going to have three 1 gigabit switches under that with a 24 port 1 gig switches, and we are going to use one copper link, a 10 gig base T link to the left spine switch, and maybe a fiber SFP plus fiber link up in aggregation to the right Spineleaf switch, because this spine switch is far away. This way, look at the math. If we connect maybe 20 hosts or 20 storage boxes or 20 servers, well, we have 20 times 1 gig connections with 2 times 10 gig links, active stacking links to the spine. We can offer a rigorous one-to-one line rate topology for those 20 servers, okay? If this time we have a 48 port switch, and if we still have two 10 gig links to the spine switches, well, with 40 servers and exactly two 10 gig links in aggregation to the spine, this time we come with a 2-to-1 oversubscription, which is, well, half line rate, but still very good compared with the old-fashioned 20-to-1 or 30-to-1 previous examples. Okay, so that's a first class of Spineleaf with very straightforward dual home 10 gig connections for all the 1 gigabit switches in aggregation to the spine. Now, if you want to get serious about Spineleaf because you have a line rate requirements for all your device in your challenging work group or your subsidiary with a lot of traffic going east-west, then you can use those 48 port switches as leads, and then this time use all 10 gig ports that are available on these 1 gig switches, meaning 2 copper ports and 2 fiber ports, so that you can have up to 4 stacking links in aggregation to the spine, and this time offer line rate one-to-one capability to up to 40 servers on each leaf, okay? So that's the typical application when really the requirement is unstoppable network operation, because again, if the left spine switch, the 12X, 12F switch, you can see on the left-hand side dies because somebody pulls the plug or maybe something bad happens with the power supply inside, somebody withdraw it, well, this switch will die, and instantly the right-hand switch will continue and take over layer 2 operations, layer 3 routing tables, and all the services as the new master. It means that for the leaves, there is absolutely no service interruption. Obviously, the bandwidth becomes less during that failure on the left-hand side, but still no service interruption whatsoever if every single host, every single connection is dual homed on the both spine switches. Okay, so now I think it's enough with this presentation. I hope I am going to show you really how we can do that, okay? So keep going on the chat box. We see a lot of questions right now going on, which is good. I'm not going to answer any of those as of yet, but keep going. We are right on schedule. 20 minutes of demo right now, hands-on demo, and then we'll address all your questions. So guys, keep me honest because I'm going to do now a screen sharing. Okay, so you see this PowerPoint slide on the background just to help you understand how this setup works today. We have two spine switches at the top, a 8x8F 16 port of 10 gig on the left, and a 12x12F other spine switch on the right. Those two switches are really meant to become the master switches, okay? Because we want them to handle the management for the entire stack. For leaves, for the sake of that demo today, we are going to use only two leaf switches, a 24-port 28G and another 48-port 48G under that. And I prepared this little diagram so that we can know in advance which port we want to convert into stacking ports, okay? So right now on that video, you can see that I'm hooked with my console cable, which is a mini USB cable to the first left 8x8F spine switch. And I have one Ethernet cable coming from the rest of my network in order to bring network connectivity and internet to that left switch. All these switches are purely factory default out of the box, okay? The only thing we paid attention to is that they all run the latest firmware. Why? Because when we set up a new stack, the best practice is really to make sure that all switches run the same firmware so that it simplifies operation. We can do many things manually. We can handle that separately. We can use provisioning. We can do a lot of fancy things. But today, I really want to go classic and show you how simple it is when we just follow these basic instructions. Go with new switches running the latest firmware across the board. So with my console and my TeraTerm, I'm going to log onto my first switch because I need to access the web interface. But in order to access web interface, I need to know the IP address, right? And this is going to come from the console because there is a DHCP server somewhere else in my network. So by enabling that console, I'm going to do show IP management. And you can see that this IP address that was given for that left switch is 1081.168. So let's go to the 1081.168 together and log to that web interface. Obviously, everything we're going to do right now could be happening through the command line. But for the sake of that demo, we are going to restrict the command line to the basic operations for IP, and we are going to set up all this using the web interface. This is the typical latest 12.0 web GUI that is running in the 4300 series. You see the system tab, switching for layer 2 operations, wiring for layer 3 operations, QoS and security, and so on. We are going to stick with the system tab, which is the level 1, if you wish, and going to first device view. We are going to see that 8x8F. Good news, we got rid of Java. So now this is pure HTML5, and you can see that on any browser. Going to the stacking submenu, let's go to the advanced because that's well organized this way. I see my stack configuration. This is my first unit. I do have only one switch in that stack. Every single switch out of the box is a stackable switch that can be run into standalone mode, but still that's a master switch into a one switch stack, right? So I confirm that this switch is seen as a management switch. Now going to the stacking ports configuration, all these ports, the 16 10-gig ports, can be turned into stacking. And right now we want to enable stacking on the fiber port number 7 here in order to go and reach the other spine switch on the right-hand side on the interface 11, okay? And because I want to use also some copper ports, I'm going to use another one, the 15, going to another copper port on the other side, so that I have 20 gig of stacking bandwidth between the spine. But because we are going to configure the stacking ports right now on that left switch, let's also configure the other interfaces that I really want to convert into stacking mode for the 12, 14, and 16 copper ports that will be used this time to connect the leaf switches, okay? So that's fairly easy to do. I see my 07 and 05. I'm going to click on the, I'm going to click on these port numbers, those physical interfaces, as well as the number 12, the number 14, and the number 16. And I am going to turn the stack mode on these interfaces, okay? Clicking apply, the system is going to take approximately 5 seconds per stacking port. So it means that I need to wait in order to let the system accomplish that mission, waiting for this. So I hope this is clear for you. We are just turning the stacking mode on those ports in order to activate stacking. This is done. Now see, the configured stack mode is actually stuck for the interface 7, 12, 14, 15, and 16. But the running stack mode is actually still Ethernet, because my switch will only perform that change live after reboot. That's why we need to actually reboot a switch before making that switch, either creating a new stack, either joining a new stacking topology. Okay? That's all I need to do on that one for now. So let's go to Maintenance tab. Let's go to Reset. Let's ask for a reboot, and we are going to save the configuration prior that reboot. Okay, done for this one. Now let's go to the right-hand spine switch together. I'm going to disconnect the console port and going to the second spine switch. My Ethernet cable is going to be moved as well, and we are going to have that switch catching a new IP address on my network. This time, I am going to have a new connection in my COM serial port interfaces. I see the new COM9, that should be this one. Pushing enter, logging in. Admin is the default admin name, no password out of the box. Bingo, I have my 12x12f showing up, enabling the CLI, going show IP management. And now I see that this right spine switch just caught the 187 IP address. Let's log to that IP. Oops. 157, I'm sorry. I need glasses. So, device view, I should see my right 12x12f 24-port 10-gig spine switch. I want to enable stacking mode on those corresponding physical interfaces in order to form my spine leaf stack. So let's go. Let's stick with that system first tab, going to stacking, going to advanced. Everything is okay. By the way, there is a fairly important thing that we just forgot, but let's go back to the process. I'm going to go back to the port configuration. This time, we want to enable stacking mode on 8, 10, 11, 12, and 22. That's a mix of copper and fiber. You can do whatever you want, up to 16 ports of 10 gig per switch enabled for stacking copper or fiber, pick and choose. So 8, 10, 12, 11, and 22. I just need to turn the stack mode on and click apply. Again, 5 seconds. Now it gives me some time to talk about something extremely important that we forgot on the first switch. So we'll go back to that first switch before anything else. In the stacking topology, that's not unique to NETGEAR. Every single stacking platforms behave the same. You need to have a master switch handling the management and the backup master switch handling the rest, the redundant mode, and then members. And a stacking topology usually comes out of nothing based on a fairly automatic process. We don't want that because we want to force the left spine switch role because that switch is really meant to be the master, right? And the second right switch is really meant to be the secondary master for the redundant mode. All other switches, we don't want them to handle the management role. That's not how this spineless topology works. So in order to facilitate that, we can actually set up the priority level for each switch so that from unassigned priority, we can attribute, provision the highest priority to the switch, meaning to be the master switch. So the right-hand switch right now is meant to be the secondary backup. So we are going to go back to that web interface. I see now my stacking ports. They all run Ethernet, but I converted them right now. I'm going to go back to my stack configuration. And for that 12x12x switch, I am going to go for a 10 priority. 15 is the highest. We are going to attribute 15 to the left spine. This one, we are going to go 10, and we'll go 1 for the little 1 gig lead switches, okay? Clicking apply. And because my ports right now are correctly configured into stack mode, but they still run in Ethernet mode, I need to provoke a reset so that I reboot, saving the configuration prior to that. Okay, so let's go back to the first switch before we continue. Just moving my Ethernet cable. I hope this first spine switch will catch the exact same IP address. Again, that's the case. My DHCP server remember, which is good. We are going to go back. This switch has rebooted, but we need to go to the stacking mode, advanced, and configuration, and we want to assign the highest priority to that left spine switch so that we make sure that this switch will catch and really run the management role. Okay, that's done. I'm going back to the maintenance tab. I want to save the configuration because, well, everything we do, you know, it's on the RAM, but in order to survive a reboot, you need to write that live configuration into the startup config file. That's how you want to do it using the GUI, saving the configuration. Okay, so going back to the diagram we just did and performed the reboot for the two 10 gig spine switches. Now real quick, we can move the console cable to the first 28G leaf switch, moving the console cable to know which will be that IP address and connect the Ethernet cable into it and see which IP address that 28G just got. So new connection, I see a COM number 10. That should be about it. That should be my new switch. Pushing enter, admin, no password, yes, 28G, perfect. Let's enable that CLI. Magic formula show IP management gives you the 57, 108157 that the left first leaf switch did catch. Okay, 108157. We are going to log into that 28G. This time, device view, everything should be all right. I have only one active connection over here. This new HTML5 visualization is great. You have access to pretty much the whole interface configuration right through it as a shortcut. But let's go to the stacking advanced stack configuration. Let's start with that priority thing. The leaf switches are meant to be very dumb members of that stack. So the lowest priority shall be given to them so that we ensure they will not fight for the master election. Apply that, new switch priority 1, and going to the stack port configuration on that 28G, I don't really need 4 10 gig ports, right? Going to the spine because I have only 24 1 gig ports. So that for line rates, 2 10 gig ports are sufficient. Let's catch and pick the first copper and the first fiber ports, 25 and 27, right there. Turning them into stack mode, clicking apply, that should be 5 seconds times 2, 10 seconds of wait. That should be all right. And we know that the running mode still is Ethernet, so we want to reboot that switch now before joining any new stack. Going to the maintenance, reset device reboot. Yes, I want to save my configuration before that, and done. Okay, now going to the last and fourth lift switch, the 52G at the bottom of that stack, moving the console port, moving the Ethernet cable. The console port with the mini USB cable is actually great just to learn which IP address. You have other means of doing that. You can actually use LLDP from a host switch in order to see that as well. But obviously the console is the fastest. Stereo, COM11, that should be this one. That's usually incremental. Okay, admin. Boom, 52G, perfect. Enabling, show IP management. Here we go with the 171. That's our last fourth switch, the right spine switch, admin. Device view, just controlling we have our 52G, that's perfect. That should be our fourth switch at the bottom. Going to stacking, advanced, configuration, setting the priority to the lowest one, going apply. And this time in the stack port configuration, because we have 48 ports of 1 gig and because we really want to experiment the line rate capability of such a spine leaf topology, we are going to enable stacking on the 4 available 10 gig uplink. Okay, so 49, 50 copper, 51, 52 fiber ports. Let's tag them all in stack mode. We are going to wait for probably 15 to 20 seconds. But after that, let me show you how we are going to form that stacking topology. That is going to be very smooth in theory. We'll see. We are still waiting for the Ethernet mode. Perfect. Now the stack port is configured. We can actually spend 20 seconds over here to say show stack port if you want to have the exact same information. We will have the very same in the CLI. At the high level, everything we can do on the GUI is obviously available in the CLI and vice versa. Okay, going to maintenance, resetting the platform, saving the configuration prior to that, and it's okay, we just reboot it. So now, if we want to recapitulate, we just prepared the 4 switches. So that's maybe 1 minute or 2 per switch, logging in and activating the stack mode. I'm going back with my console port to my first switch, I'm plugging my Ethernet cable back to the first switch, and now we want to form that super high-end, efficient, highly available spine leaf stacking topology. How are we going to do that? Because we prepared the switches on purpose so that, you know, we kind of provisioned operations already. We are going to shut down the power for these for the right-hand spine switch, because we want to make sure that during the boot, this right-hand spine switch will join the boot as its place, meaning the secondary master, and we're moving power from each leaf switch as well in order to achieve the exact same thing. So as you can see on my video, only the first left 8x8x switch is still alive, okay? Because this one is meant to become the master. It's already the switch number 1 in that topology. I don't need to reboot him. Now we are going to return power on the first switch, which is the right-hand spine switch, okay? The boot will take approximately 120 seconds. We don't have to wait for all that time all the way, but we just want to make sure that the stacking detection is triggered before powering the other switches. What you see right now is really the best practice. It's always better to do that this way in order to do things manually. Again, there is plenty of other things, but going through the best practice process really ensure 100% success rate for your installation, and that's what you want to do. So the second switch was powered. The switch is actually right now going through the boots. I forgot to light up my console. I should go back to my first left switch to see what's going on. That should be the column number 5, if we remember well. Yes. I mean, we are logging onto what will be the master switch, the top left spine switch. Enable. And now we can power the 2 leaf switches. Let's do that. We're plugging the power codes onto those switches. They are now booting. I think we should see now the number 2. I hope you can see that. Maybe not. On the small LED on the right-hand switch, I see the 2 here locally. It means that this switch is now the second switch in the stack, the second spine. That's what we want to do. So going to show IP management, just controlling that the management IP address didn't change, 1081.68. That should be it. Going back to system, going to stacking, we still don't see the second switch, but that should update. That should come at some point. We should see, oh, by the way, that's the demo effect. Nobody noticed on the chat box. We did not physically interconnect those switches, so that can't work, right? We just boot those switches, but they are still not physically connected. That's my fault. Okay, guys, we need to shut down the 3 switches. I'm sorry about that. Before powering up those switches, we now need to make sure we have those physical connections going on. Okay, so let's link all these switches together with those ports. Port number 15 over here to the port number 22 on the right-hand side. Over here, yeah. Then, going with the fiber ports, we are going to link the very first fiber over here. Only the master switch is powered on. The other switches are obviously powered down right now. Going to the last one over there. Okay, so now I have my 2 spine switches connected together. Let's now connect the first leaf switch underneath. So the port number 12 over here, Okay. Right here, going to the first over here. And taking a fiber port for the second master switch on the right-hand side, the second spine, we are going to use the connection number 12 over there. Perfect. And connect this guy. Okay, we are almost there. Now let's connect the second leaf switch. We have this time 2 copper connections coming to the interface 14 and 16, the last 2 of the left spine switch. So let's do so. Over here, and let's have the second link established right now. In this position. Okay, almost there. We should have now 2 fiber connections connecting the 2 fiber uplinks on that second leaf switch, this time going to the port 12 and 12, meaning the last 2 fiber ports on the left spine switch. So connecting the first one over here and connecting the second one using DAC, direct attach cables, over here, going to the second port over there. Okay, so now the cabling was done, hopefully correctly. We can now then power back again the second switch, the second spine switch, in order to process the stack and force trigger the detection with the right second spine switch. Let's wait for only 1 minute, maybe not even 1 minute, so that we can actually power the 2 leaf switches and just wait, see them popping up on our web interface for our master switch. Let's go. So now we just powered the 3 switches back. I took a 25-second dance on the right spine switch in order to make sure this guy can be elected as the secondary master. So I should be still in. Yes, I'm still in my 8x8F management GUI. I can close the other ones that will be not used anymore. And going back to the video, at some point, we'll see a number 2, a number 3, and a number 4 in the LED numbering. So I already see physically the number 2 on the right spine switch, and I still see 1 on the 2 other 1 gig switches underneath because they did not boot as of yet. Okay, so good news. Clicking update on my web page, I now see my 8x8F. That's me. I am on that switch, being the management switch. But I see now the second spine switch, the 12x12F, right? The second one over here on the right-hand side, directly set up as the number 2. That's what I wanted. And now clicking, I see stack member. That's a done status. If I click update again, that's super good because now the 12x12F just was set as a operating standby mode. It means that this switch with its 10th priority now handles the backup role as a supplemental management unit should the wheel number 1, the master unit, fail. So that's perfect. And see now, I see the unit number 3 and unit number 4, 28G and 52G, that just popped up. let's make sure everything is final. I see update. I see my 4 switches in my stack. Go back to the device view. Just for your pleasure, you should see now 4 switches in your logical unit, because now, guys, you have a fully functional stacking topology, which is actually a spine and leaf topology with line rate capability for pretty much all the gigabit access ports, thanks to that double home, thanks to that spine just above them. So I want to show you 2 things before we go through a QA, going back to the stacking, how this NSS feature works, in order to make sure that's fairly automatic, but you have basic stacking advanced and NSS feature summary enabled, so that you actually make sure that you have this seamless failover capability enabled, and that's what you can confirm here in your stacking configuration with the operating standby. So if the master switch reboots or fails, that second switch will handle the management role without any service interruption for the rest of the stack. Okay, stacking port configuration now. We see the ports that are up directly over there. We can actually display them all because now you have a big switch with many blades, right? And the last thing I wanted to just show for your understanding today, going to the Layer 2 tab, going to switching, going to lag or link aggregation. Now that you have a big switch, you can actually set up a predefined lag number 1, and you see 4 blades in your virtual chassis. You can actually give a name to that lag, and the dual home host A can, for instance, be, I don't know, the port number 3 in your first unit and the port number 3 in your second unit. You can actually disable this static mode because you want that to be LACP. You have this hashing protocol, always go with source and destination IP and TCP UDP layer 4 ports hashing for the best performance. Enhanced hashing mode should be reserved in between NETGEAR switches for perfect interrupt with any other class of server or hypervisor. Go with the number 6 service and destination IP and TCP and click apply, and you set up a distributed lag across 2 switches. That's where you want them to be on your spine. So that concludes our demo today. Going back to my stacking, I should just confirm that everything is running now perfect. That will survive to any kind of reboot moving forward. I am going to stop the screen share and going through the questions, unless the operator tells me otherwise. Thank you for your attention today. Let's go over that.
All right, so we will give you a couple of minutes for just a few questions, and then we've got to let everybody get back to their day. So thank you so much for that presentation, Laurent, and that awesome demo. Let's get to some of these questions. Can any of these models function as a centralized layer 3 access switch?
The answer is yes. That's a fully functional switch that is composed of a stack that can be fully dynamic layer 3 routing switch across all members. Yes.
Awesome. For your lifetime warranty, how long do you continue to push firmware updates?
So that's a very good question. During the life cycle of the product, we have, monthly, weekly, quarterly updates based on bug fixes and customer enhancements. When the product goes EOL, maybe after 5-year windows, we will only do bug fixes. So to answer the question, we will fix those bugs when we must.
All right, fantastic. Is the security on the M4300 more secure than a NETGEAR wireless router?
Oh, that's a fairly good question. The answer is yes, definitely. We have super high-end access control filtering capabilities so that we can filter or block or refrain or shape traffic based on TCP, UDP in both directions, ingress and egress on all ports. So we do not have NAT. Don't compare that to a router with a firewall. But without NAT, using ACLs, we can be as secure as any super high-end firewall.
Awesome. Can you assign port to VLAN?
So that's a fairly good question. Yes, that's basic static 802.1q VLANing, right? So we are going to declare VLAN 10, VLAN hundreds, VLAN thousands on the switches and statically assign ports to those VLANs. The answer is yes. That's for the ports. For the IP address, that's the same thing. In routing mode, every VLAN will have its IP address, routing IP address. That will be the logical IP address for the entire VLAN.
All right, we'll get a couple more. Aaron wants to know, are any or all of these PoE?
So that's a very good question. Yes, on the 1 gig switches, we have two models, 24 and 48 without PoE, and another two models with PoE. We can scale with that very same spine leaf technology using PoE on those leaf switches up to the full PoE plus provisioning going with the big PSUs.
All right, awesome. So Shelby mentions your diagram showed small to medium-sized businesses. What would you consider a medium to large-sized business, and will these work in a larger environment, and how easy are they to maintain? And that'll be the last question that we'll take. Okay,
thank you. So the answer is, typically SMB for us goes up to 500 seats. 500 seats, meaning 1,000 nodes. That's where the heart of our business is. And it doesn't mean we cannot equip highest grade enterprise accounts or big campuses, but we are not going to do that across all layers from the access to the core. So up to 500 seats, NETGEAR can equip the entire network down to the edge up to the core in a larger enterprise accounts or in a very large campuses, such as those campuses we have with large universities in the US. We will be mainly at the edge.
All right, fantastic.
Can be the server access as well. Thank you so much for this opportunity today.
Yeah, thank you. Do you have any final words for our audience?
Yes. As a conclusion, I saw one or two questions quickly around pricing. And at NETGEAR, we want to be very humble. We don't want to display strict prices like that in a presentation. Those things can move, and NETGEAR as a vendor doesn't decide the strict price, by the way. But I just want to give you that hint. From a pricing standpoint, the 4300, the NETGEAR top of the line retails, if I can speak like that, going to CDW or any other DMR or online shop, retails around 20 to 25% of a equivalent Cisco 3750. So those switches are tremendously cost effective. I can give you only one example today, a 16-port 10 gig spine switch, as you can see on the left-hand side with 8 copper and 8 fiber, should retail around $1,400. So I hope that concludes this presentation and add some colors on that line. Thank you.
All right, fantastic, Laurent. Thank you so much. I do want to say special thanks to the NETGEAR team and Laurent for creating today's content and for sponsoring this great event. We do have a lot of questions that we weren't able to get to, so we will share those with the NETGEAR team and have somebody reach out to follow up on those questions with y'all. If you have any if you had to step out or miss any part of this presentation, we'll also be sending out the recording to view on demand, and we hope to see you back next time for another SpiceWorks Partner webinar. But until then, stay safe and keep it spicy.